All right. So every degree is just writing away. Thank you. One day. Okay. 1 degree is 60 minutes, and 1 minute is 60 seconds. Unfortunately, for all of us, they decided to use the tick mark for feet for minutes, and the thing for inches means seconds. So welcome to confusion. Okay, you'll be all right with it though. At least you realize you've seen it before. Okay, now seriously, it's really hard for me to concentrate while there's so many side conversations. So if you don't need me, please maybe do something more quietly. Okay, and so my conversion, like if I have 1 foot, is 12 inches. You know, you can multiply by 1 foot over 12 inches, or you could say 12 inches and 1 foot to convert whichever way you need to go. If you want to go to feet or if you want to go to inches, use your conversion. So if I want to go to minutes, or to, if I want to go from minutes to seconds, I know that there's 60 seconds in every minute. I know there's 60 minutes in every degree. All right, so if we take this, 42 degrees, 52 minutes, and 48.82 seconds. What happens to a decimal of a second on the surface of the earth is relatively small, but is even more precise. There's not something after seconds, okay? So what I would say to do is say 42 degrees, and this is 52 out of a possible 60 seconds, and this is 48.82 out of a possible 3,600 seconds. So what happens is if you take 52 minutes and divide it by 60 minutes, do you see it'll give you the correct decimal? So try that. Get out your calculators, and I'll get one out too. And I'm going to type in, let's see if I can get it to where we can see everything. All right, so I'm going to be typing in on my home screen 42 plus, I have 52 minutes, so that's 52 out of a possible 60, plus 48.82. Order of operation will take care of it. Now, girls, why am I dividing that one by 3,600? Time out. The parentheses wouldn't hurt anything, but I only need them here by order of operation. Also, let's time out. I really preach being efficient. Sometimes you don't even notice it when I'm teaching you something. Or we have discussions like, yeah, you could do that, but why not be more efficient? I'm sure that our book and a lot of places you would look probably have you stop and convert 52 divided by 60 and get a decimal. And then convert your seconds to degrees. 48.82 divided by 3,600, and you've got these two nasty decimal places to add together, then add it to 42. I just like to be efficient, just do it all at once. Do y'all see what I mean? Okay. And so now if we hit enter, we get, and you'll round it to 3 decimal places for me. So that also is 42.880 degrees. So you could give it a decimal or degrees, minutes, and seconds. Those of you that will be engineers, you'll just have to watch for which one you need. I'll teach you how to go back and forth, okay? Now, does that make sense? Wouldn't you think 42 degrees, 52 minutes would be getting really close to 43 degrees? Because 60 minutes would have landed me on 43 degrees. So let's talk about why I did it this way. If I did 60 minutes, then I actually have gotten to another degree. Do y'all see what I mean? So 60 minutes over 60 minutes is just 1 degree. Okay? So do y'all understand why mathematically I did what I did? Okay. Now at this point, it hadn't happened yet. I'm surprised, but at this point, there's usually a student that goes, wait, you could do it on your calculator this way. I'm going to show you. You can fumble around and find these buttons. I just don't like, y'all know me already, that I don't like going to a lot of menus. If I'm in a hurry and I'm working a lot of problems, I do it this way. This is the way Miss Lazari does it. But if you want to be fancy and slower. You could go to 48, go to second angle. Well, first of all, I've got to be able to read it. Where's angle? What should be there? Hang on. You probably see it, I just don't. All right, 48. There we go. Do you see there's a little degree circle? Then I can go 52, second angle, and I can use the minutes, but I didn't see seconds. So then I can go 82.82, or 48.82, sorry. 48 point, I'm already aggravated, 82, and I can go find this little, sorry, it's so hard to read up here. Down here, I think. No, that wasn't it. It's above the plus sign, isn't it? Yeah. Oh, but it's alpha. It's green. Okay. And then I could hit enter. And then I could have the answer. I don't want to do all of that. I don't want to go to second angle. I feel really cool, but I don't want to do all of that. Do you see I can just type it in straight and get the same answer? But I did want to address that because at some point somebody's going to whisper in your ear, hey, there's all these angle buttons. I don't care. Oh, sorry. Oh, wait. Oh, that's just because of your teacher typing in 48 instead of 42. I'm sorry, I just mistyped it because I'm so aggravated with the stupid menus. That's really cool if I needed it. Thank you. Can I keep going? Yeah. Okay. Sorry about that. That's just me typing it in incorrectly because I'm so caught up in the inefficiency of the angle thing. Okay, girls. Now, let's go get this one. And let's go back the other way. All right, now you're going to feel like that I'm hypocritical. Because in a minute I'm going to show you a different way to do it that might surprise you. The way to logically do it, like I logically do this one. The way to logically do this one is realize, okay, I got 42 degrees. I would just write that down somewhere. And then I have 0.88022278. And that's like this. All right, so I have 42.88, what was it, 02? Something, okay? This is out of 100. 0.8802, blah, 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 is based on the decimal system. What's the word deci? Decimal system implies that you're working in base 10 all of a sudden instead of depending on 60. So I'm looking for minutes. This is like 0.88802. I want to know what that is out of 60 instead of out of 100. Do y'all see I'm setting up a proportion? Because right now this is let's say if I have 0.5. Okay? Isn't that 5 over 10? But I want to know what it is out of 60. Okay? So I'm going to multiply my decimal by 60. When I multiply it by 60, it's going to change it to minutes. Do you see I'm trying to get it based on 60? Okay? Does that make sense? I think so. All right, what should 32.5 degrees be? It should turn into 32 degrees and 30 minutes. Let's see if this little process makes sense to you. 0.5 is the same thing as 5 out of 10, but I want it out of 60. So if I multiply both sides by 60, the number that I'm looking for is, let's cancel this. Do you see I get 30? Do you see how that worked? I'm going from decimal to this base 60 thing. It's not really base 60. I shouldn't be saying that. All right, so what you can do every time is just multiply it by 60. So somebody take this long, or I'll do it. So what I'm going to do on my calculator is I'm going to get rid of the 42 because I'm already writing this down. So I'm going to say 40, hang on just a second, Nicole. I'm going to have 42 degrees. And girls, I'm trying to change this into minutes and seconds. So what I'm going to do is get rid of the 42. because I don't really want that in there. I know I've got 42 degrees, okay? Now, when I multiply it by 60, all that's going to do is change it into minutes. So now I have 52.813 minutes. So I know I have 52 minutes.
You just round that off to the ones?
Nope, 52 minutes.
Oh.
And now this leftover decimal, be logical about it, is the seconds. Let me pull this back up. Right, Nicole? Oh, I'm hitting the wrong thing. I'm sorry. Now they're telling me it'll open up. Okay, so what's happened is now I've multiplied that by 60, and this is how many minutes I have, but now I have part of a minute, which is a second. Don't multiply by 3,600 because you're already in minutes. You just want to go to seconds. So you multiply what by 60?
0.8.
All right, so the fast way to do that is maybe just to get rid of the 52 now and multiply that by 60, and it'll give you the correct seconds, which is 48.82, which isn't that what it had on the other screen?
Yeah, that's what I'm sure.
48.82 seconds. All right, here's where I'm hypocritical.
Wait, and that's the smallest you can go.
Yeah, there's not a word for seconds, and so you just have a decimal of a second at that
So then you're
point.
back to the
I mean, there's
tens.
not a word for something smaller than seconds.
Okay, so then you're just back to like the tens thing.
Yeah, kind of weird. But now you're between 48 and 49 seconds. Okay, so
Wait, which is, sorry, but that's still more than a mile, right?
seconds, maybe not, because you're in seconds. You're not in minutes.
Is
A degree is about 70 miles. So a
So
minute's
divide
about
that
a
by 60.
mile.
Okay.
And you could type in pretty easily how big a second is on the surface of the earth, but it'd be a 60th of a mile. All right, now, so calculator-wise, I felt like that was more tedious than I like. So I like to be efficient, so I know about the angle button. So this is what I actually do. I go 48.880227778. If I want to change it to degrees, minutes, and seconds, I use this button. Second angle, and I'm going to hit what? 4. What does 4 mean?
That's degrees.
Degrees, minutes, second. We call that DMS, degrees, minutes, seconds. Okay? So, if I'm going to degrees, minutes, and seconds, I use that menu. If I'm going from degrees, minutes, and seconds, I go the other way. So we'll do some problems and then we'll go on, okay? All right, so have your calculator out, and let's do this. How would I change 36 degrees, 15 minutes, and 42 seconds? I wouldn't go find the degree, all the tick marks and everything. Do y'all see? I wouldn't. You can. It's under the angle key. But what I would do is type it in one fell swoop. I would go, let me clear this out. I would go 36, and then I have 15 out of a possible how many minutes? 60. And I don't remember my other number. 42 out of a possible how many seconds? Right. By the way, if you just divide 42 by 60, all you've done is convert it to minutes. You want to go all the way to seconds. And then you'll write 3 decimal places or more on your test or worksheet or whatever. So now I'm not going to shy away from you seeing those in homework problems. You can convert it to decimal and then continue on. Okay? By the way, I'm going to talk about your answers, girls, have to be my answers as we're working the law of sines and law of cosines problems. Your answers have to be exactly mine, and your friends will be. So yours need to be too. So don't, like, if yours is off, when I require 3 decimal places, if I have 332 and you have 334, I'm counting off. Because think of where you're headed in your life. You want to be precise, whether you're operating on someone's eye, flying an airplane, launching a space shuttle, whatever it is you're doing, you're the ones that better know what you're doing and be precise when it's required. There'll also be times to estimate that we'll talk about more in calculus, okay? So I like to go to decimals like that, all right? But if I want to go back, suppose I have 39.826 degrees and I want it in DMS. That's when I use the angle key myself instead of all that times 60 stuff, okay? So I already forgot my number. 39.826. So I would go 39.826, and then I would go second angle and hit DMS and just let it do the work for me. Okay? All right. So, let me look at my list of things to do. Okay, I'm going to page 410 now. Let's look at number 11 in your homework. 410. Have your calculator out. What mode do you need to be in for law of sines and law of cosines? Or you'll miss every problem. Okay, so make sure you're in degrees.
And I was like, I think I'm gonna check.
Yeah, always make sure you check your answers too. I'm going to check my mode here. I think I'm in radians. So I always want to check now. And right now I'm in degrees. You're starting to, kind of learn when you need to be in one or the other. I would have your calculator out because of what I'm about to show you. There are times that I want this number. In the old days, like a couple of years ago, the calculators that people were buying, you couldn't go up and copy that down there, okay? Or sometimes in law of sines, you do an awful lot of work on your calculator, and you have to scroll way up to get that number. Suppose that that's side, or that's an angle. Suppose that's angle A, and I'm working on law of sines. I can actually store it, and I expect y'all, I want everybody to listen. If you're in the middle of a law of sines problem where you still got to find more angles and more sides, if you round that off to 36.261 or 262, you've rounded off maybe a fourth of the way through your problem. You use that to find another answer, use that answer to find another answer, and you might use that answer to find another answer. What can happen along that trail is your decimals could fall off of my decimals. Okay, is that what you were saying, Chloe?
That's just gonna get
Yeah.
wrong.
I want you rounding to 3 decimal places as the rest of the world does at the end of your problem, okay? Not while you're working the problem. And so you want to either keep track of that entire number or store it. And it's up to you. You just find your own way and check your answers with my answers, okay? So to store it, do y'all see this stow button down here? It says STO, okay? So I can store that. I'm sorry, it's this one. Store it. It's the one right here. It's red. It just highlighted. You'll see it. It says stow. Okay? It sounds like they're from the South. I'm going to the stove. Except for really in the South, you'd make store about 7 syllables. Like, I'm going to the store. Store. My husband's name is Jed, but my brother's name is Jed. And so I grew up saying, we can make it last a long time. Jed. He's like, my name does not have 3 syllables. Okay, so anyway. I can store and go alpha A and enter. And now every time I hit A, until I change it later, it'll be that number. I used to have to really teach and preach that, okay, how to store something using the stow button, all right?
Can you use any letter?
Yeah, but it kind of makes sense if you're working with, yes. You might be working with a triangle that has D, E, and F. I wouldn't ever store anything as X, just because you use your X key a lot, okay? Here's some things that you need to watch out for, and this is super serious. A lot of times I tell you mistakes I'm prone to make, hoping you won't make them, but most times you have to make it in homework for it to really hit home. When I start to store things, a lot of times I forget when I'm on a new problem to store, I don't know if that makes any sense to you yet. But if I've just worked a problem and I've stored something for A, and I get to a new problem, sometimes I forget when I find the new angle to ever actually store it as my new A, and without knowing it, keep using the old one. Like for instance, on this calculator up here, angle A, or letter A, is gonna be 36.26166 until I change it to something else, every time someone pushes it. These days, most of your calculators, and about all of them, have the power to scroll back up and just bring it down again to where you don't have to store. Or you can write it all out. Find your own way. I'm going to be modeling it on a problem. So here's number 11. All right, before we go to 11, let's talk about where we ended the other day. This couldn't be more important. There is something in law of signs called the ambiguous case. If you don't know what ambiguity means, it's like, oh, I can't decide if I want pink or red. I can't decide if I want M&M's or Reese's Pieces. Sort of ambiguous. And so you can get me either one if you're going to run around to the store and everything's changed so much. You can't go to Diva Filippo, you can't go to...
So sad.
I know, I can't say go to
Apparently
Diva.
Butterfield is
Anyway, if you're going to go somewhere and get me you could go get me candy there, but it's got a weird name. Okay, anyway, ambiguity means it could be either one and I'm not going to be mad at you, okay? So if I'm saying, Brianna, run to the store and get me some candy. And she goes, what do you want? I might go M&M's or Reese's Pieces, okay? And I might be mad whichever one she brings back. It's ambiguous. But if I go M&M's, then I'm going to go, I didn't want Skittles, I wanted M&M's, so they're very different, okay? Y'all see the difference? So ambiguity means, in fact, it's really more than that, I'm sorry. Let me give you another example. Let's don't send Brianna to the store. And I give this example every year. When I had a house, and I actually had a kitchen worth redoing that was large enough to even think about redoing. Now my kitchen's as big as this thing right here. But anyway, I don't even know how I'd redo it if I wanted to. But when I had like a house with a kitchen, I wanted to put tile floors in instead of whatever was in there. And at the time I was a single school teacher working mom with a budget. I'm still on a budget, but not as bad of a budget as I used to have back in the day. But I really was redoing this house and I wanted a big kitchen floor. So a lot of my other friends that had more money than me had these fabulous new tile kitchen floors, so I was doing the best I could. And so I get some advice and some recommendations of people that could put in a tile floor for me. And this guy named Frankie was really good and affordable, and he would also install it for me. And so he came, and in fact, Miss Arkin's kind of going through this because she just moved apartments. And she picked out new shades and new this and that and the other thing. So anyway, Frankie asked my budget, and Frankie comes to my house with a sample of a tile, and he goes, this is what you can afford. I loved it. It was great. It was awesome. He's like, this is what you can afford, and he installed it, and it looked fabulous, so I was really happy. However, what if I'd gone over to my friend's house, and I'd gone, ooh, I like that color better. Who did your floor? Frankie. This didn't happen, by the way, but it's happened, and you've all had it happen to you in some form or fashion, whether it's a dress or shoes or a floor. But anyway, what if I'm like, ooh, I really like your floor. Who did your floor? And you, Frankie. And I'm like, wait a minute, how much did you spend? Same amount. And I go, why didn't he tell me about that color? Because apparently with Isabel, he would have gone, here's your choices. What would I want Frankie to tell me? Well, why didn't he tell me that? Okay? Like, for instance, I don't know who all this belongs to. I don't know, I can't think of a better example, but I know there's times in my life where I've looked at somebody and go, where'd you get that dress? Or, where'd you get that whatever? And I'm like, but I was just there. How come I didn't know that it was on the rack, or maybe it was at H&M and it was back in the back? Did y'all ever look through that rack in the back where people are coming out of the dressing room? I always see things when I'm coming out of the dressing room in a store that I really want. But anyway, you may have that feeling of, wait, why didn't you tell me about it? One day when you're a professional, let's say that you're a doctor, and this has happened, where you go and visit a doctor, and they say, you need your wisdom teeth out. Okay? It didn't happen to me, it happened to a friend. It may have happened to me. I got my wisdom teeth out when the dentist said so. But I've had a couple of friends that like, you've got to have your wisdom teeth out, or we can watch it for 5 years and maybe pull 2 of them and see how your mouth settles. You would really want to know those choices, wouldn't you? You could go to the doctor and go, I can give you an antibiotic or a shot. That's happened to me before too. It's probably happened to you where you're sitting there and your mom's about to, or dad's about to make the decision, and you're probably like, antibiotic, antibiotic, antibiotic,
That's
antibiotic.
like a flu shot or miss.
But why do your parents choose the shot? Because you're going to get well faster, and you're not going to forget to take it, okay? But what if you went to the doctor and they go, I'm going to give you a shot, and give you no choices, okay? So do you see what I mean? It is on us to tell somebody about both triangles, because they might not like the one that I give them. They might have wished that they'd known about the other triangle, like this.
For any of the ambiguous cases, like, wouldn't the large, like, one angle has to be larger than the other? Wouldn't that one, like, not?
We're going to talk about all of that,
Okay.
okay? Hey, girls. In this one, B is 9, A is 4.9, and little a is 30 degrees. Person A and person B has the exact same budget. They have the exact same kitchen, they have the exact same budget, okay? And so I'd be really mad if they only told me about this dark one. What if I like this other one better? Do y'all see? Those are both options for me, and it's on me to tell somebody as a professional. You could do this acute angle triangle, or you could do the obtuse one. And they should be able to pick. Do y'all see what I mean? They have the exact same components, okay? Now, this had happened to me in redoing my house and other things. I found something that I just absolutely loved and asked somebody to come get me an estimate, and they put everything together and gone, we're not in your budget. We can't do it. Don't have enough money to do that, right? Do y'all see what I mean? Like, they put all the pieces together, and they better tell y'all, we can't do that, all right? Sometimes there's only one way, and we're going to learn about that today. Nicole started sort of talking about that. So here we go. Let's look at number 11. Here's the problem. I'm sorry. I want to go back to this one more time. This is important enough to spend time on. I talked a little about the hinge theorem in the last class, and it's extremely important. Do you see how we don't know the angle between the two sides they gave us? Later on, we're going to look at some problems where I know that angle, and that's a blessing. If I know this angle, then it's set in stone. Do y'all see what I mean? The third side can only be one thing, okay? But if I don't know how these are hinged together, I have a problem. It could be acute or obtuse. Let's think to what happens with law of sines. At some point in law of sines, you're going to have to push the dreaded inverse sine button. Why is it a dreaded inverse sine button? You know from your memo quizzes, which you'll have one on Friday. What's today? On Thursday? Maybe? I don't know. I can't remember. Yeah, memo quiz on Thursday. It'll only look in quadrants 1 and 2. If you're doing a triangle problem, it won't, I'm sorry, that's not 1 and 2. That's 1 and 4. So sorry. Okay, yeah. 1 and 4. Quadrant 4 is like not going to be happening to us right now because we're working with triangles. Are we going to have any negative angles? No. Here's the problem. When you go sine of A is something like 0.782, and you're dependent on your calculator to give you angle A, it'll go do-do-do-do-do. Found it. Here's your A. Goodbye. See you later. Isn't that also true over here, though? Maybe you're the person that really wanted that obtuse triangle, and you didn't want angle A to be like that. Do you see the difference? This leg could swing this way or this way to make that person happy. When you push inverse sine, what quadrants it's going to scan through? Quadrant 1. So whose responsibility is it to find the other option is yours. Okay? So law of sines, always be prepared for 2 triangles. We'll spend a few days talking about how you can shortcut this. Okay? Let's look at number 11. Number 11, and now I won't shy away from degrees, minutes, and seconds. So So number 11 on page 410, angle A is 80 degrees and 15 minutes. And angle B is 25 degrees and 30 minutes. And little b is 2.8 kilometers. Something I was talking about with, I can't remember who, somebody not on the front row, I think. Notice how I don't have, was that you, Isabel, that we were talking about? If you have 3 different letters, A, B, C, okay? This is A, B, C. Do y'all see if you have angle A and C, the hinge is B? If you have B and C, the hinge is A?
There's always one letter.
You've got to have an A, B, and C to know for sure what's happening. Also, you can't use the law of signs if you have 3 different letters, can you? Don't you have 2 of the same letter to even get anywhere? Okay? So I'm going to say B over sine B equals A over sine A. Now I'm going to take 80 degrees and 15 minutes and change it to decimal. All right, so I'm going to say 80 plus 15 out of a possible 60. And I'll be using this all the way through, 80.25, which a lot of you probably knew, but in case it's something you don't know. 80.25 degrees. So you'll actually see this probably on the test. On every solve a triangle problem, I'll have 2 boxes. For you to put your answer, we're going to find angle C, little a, and little b. But what if there's another option? Be ready for both with law of signs. Your calculator is going to give you option 1. I'll show you how to find option 2. Okay? Let me pause and say here, watch this. I'll show you a couple of different things. Well, I'll just show it to you here. There's absolutely no way I can have a second triangle in this problem. Yeah, awesome. Pietra, say that louder. If I have 2 angles, Pietra and I know the third angle. There's no ambiguity there. Do y'all see what I mean? They have to add up to what? So when the problem happens, and I think this is what Nicole was asking me a second ago, when can you actually run into the ambiguous case where you have to look for it? It still might not happen, but you got to check for it. When you have 1 angle and it's acute. Other than that, you don't have to even check for it. You can if you want to, but you don't have to. Why is that? If I tell you that angle A is 100 degrees, and little a is 14, and little b is 20, okay? By the way, there's a possibility that wouldn't even make a triangle, but that'll just happen in your work. I want to pause for a minute. Your book and websites and stuff give you all other things that you can memorize to know if you have a triangle or not, or a second triangle. It happens to you so fast in working the problem that I'm not a proponent of memorizing a bunch of stuff that you can forget. Like if this is greater than that. You can do it if you want to. I don't even know it myself. I just work the problem, okay? When I'm looking for angle B, eventually, do y'all see I'm going to hit sine B equals something? I'm sorry, I'm moving really fast in an honors class. I'm going to say A over sine A equals B over sine B. So eventually I'm going to get to arc sine B. Is that okay? Okay. Here's the problem that makes people anxious. Is I know this stupid inverse sine function is only going to look for an acute angle for me. Do y'all agree with that? When you go arc sine, it's only going to give you an acute angle. And what if it's obtuse and you didn't know it? It'll never check for it. Why am I so relaxed here? Because the angle I already have is obtuse. How many more degrees are left over to play with?
80.
80. So I know the angle I'm looking for is acute and I relax. How many obtuse angles can a triangle have?
1.
Only 1. If it's 91 degrees, you've already used up so much that the other 2 are acute, right?
Yeah.
So those are other little windows that I want to tell you until I can shortcut your work. The only time you're really going to be worried and amped up is maybe there's another triangle that will work for this client if I have one acute and two sides, okay? All right, so let's go back to 11. All right, on 11, I've ruled out this. Now, by the way, when you do worksheets and tests for me, a lot of times I just do that because I'm not going to tell you there are two. It could be that none of them work. They're just going to be sitting there for you to fill in if you need it. Also, girls, you would all, when I looked at your work, I barely looked at your work because isn't it just all over the place for lots of people, lots of decimals and everything? So what I like for you to do is only put your answers in the box and have all your work around. Because if your answers are exactly my answers, I can move on to the next problem. I don't have to plow through your work looking for your answers. If your answer's off, then I'll plow through your work and try to give you partial credit. So don't squeeze right now it's not an issue because your homework's out of the book again. All right, so anyway, I'm going to be doing this in class. Okay, so here we go. I'm relaxed, Pietra, because I know that angle C can only be one thing because we already have two angles. All right, so I'm going to add, these angles are 80.25 degrees and 25.30 degrees. All right, so on my calculator, this is what I require. I have 80.25 plus, what was the other one? I already forgot. 25.5. That looks like a 3. Did I write 3?
But it's like 30 minutes.
Right, so that should be 25. What did I do? Good grief. It's ready to move on, I guess. This is 25.5 degrees. All right, so here we go. I have 80.25 plus 25.5. And my other angle is definitely one that's subtracted from 180. Do you see how I continually use the answer key? Don't round off anything. So you have 74.25. However, it's common courtesy. If someone's talking to me in Spanish, if I can, I would talk back to them in Spanish, okay? I don't insist on English. Well, I do because it's the only thing I know, but besides Latin, nobody talks Latin to me. But anyway, do you see how I gave it to you in degrees, minutes, and seconds? I want that back in DMS eventually. At some point, you might want to store it if it's a long number. It's a short number. It's just up to you. I might store it. I might not. I don't think I am in this case. So now I'm going to go second answer, and I'm going to go, in case that's a long decimal, I'm going to go to angle and change it to DMS and write that on my paper. 74 degrees and 15 minutes. And you'll write it in here, 74 degrees and 15 minutes. So now I'm going to find little a. All right, little a, I have it set up here. I have 2.8 b over sine b equals a over sine a. So I'm going to cross multiply like this. I'm going to multiply these two, and I probably won't write it all down. Whatever that is going to be equal to the sine of 25.5 times a. So I'm going to multiply these two and divide by this number. You're bright enough to do the algebra however slowly or fast you want to do it, but be careful that you know what you're doing, okay? All right, so on the calculator, I am going to multiply 2.8 times the sine of 80.25. 2.8 times the sine of 80.25. If it was a long decimal, you could have stored it or gone up there and grabbed it. Don't round it off yet. And then I'm going to divide that by the coefficient of a, which is going to be sine of 22.5. So I'm going to divide that by the sine of 22.5. 25.5. Is it 25.5? Yeah, 25.5. All right, now, and remember you have the freedom to scroll back up or store. And so little a is 6.409 or 6.410. I would accept either one of those. I'll do 6.410. All right, now, I see people sometimes find the other one, see, but it's battery in there. Why can't you do that here? That's not a right triangle, okay? It's in your best interest to go back and find little c with as much given as you can. I'm going to say b over sine b and c over sine c to find little c, okay? So let's move on, and before we go, let's do a two triangle one. All right, so here's, oh, I'm sorry, that was more degrees, minutes, and seconds is all that was. Okay, I'm going to find one in here that gives me, all right, I'm doing 29. This is number 29, which was not in your homework. Might be in tonight's homework, I don't remember. I'll post your homework in a little while. 29 is, A is 58 degrees. Little a is 11.4. And little b is 12.8. Now I could have the ambiguous case. I could have triangle 1 and triangle 2. Okay? I'm looking for angle B, angle C, and little c. Do you see why it can be ambiguous? I have one angle. There's a lot of degrees left. One of them could be obtuse. So I'm going to say A over sine A equals B over sine B. I'm going to cross multiply really quickly in interest of time. So I'm going to say 12.8 sine 58, 12.8 times the sine of 58. And that answer, I'm going to divide by 11.4. Hey girls, right here sometimes you know you have no triangle. I'm about to hit inverse sine to find angle B. Listen up. If that number's more than 1, aren't you going to get error? Can sine be more than 1? Opposite, okay? So that's how you could get no triangle. That's how it could go. Well, these pieces don't even fit. Okay? All right, so now I'm going to go inverse sine, thinking stupid calculator, because it doesn't have a brain. It's just going to give me one angle, 72.212 degrees. All right, so one angle is 72.212 degrees. While I'm here, I'm going to find the other option. It could be this one, but couldn't it also be that one? So option 2, I'm going to say 180 minus that one. Okay? So now I'm going to my calculator and starting to build the second one. So I'm going to say 180 minus answer, continue using answer or copy paste. It also could be 180. Somebody could go, oh, I love the 107 degree angle. That's the one I want. Okay? 107 point whatever, because I know we need to go. Finishing up. Okay, now watch. Do you see how you could go back to this triangle and use this A and B to find your C's? And then go back to this triangle and use this A and B to find your C's. The examples in the book are really good. Wait and check assignments. It's slightly different from the syllabus. I don't feel good about a quiz on law of science next class, so we'll have that probably Monday of next week, okay? But you will have a memo quiz and book work for Thursday. All right? Thank you. Bye, girls.